This is problem 2, section 3.5. Here is my question. Here is my function fx equals 2x minus 3 over x plus 5. There are several questions, but basically this is a question about sketching the graph of our function. Okay. This is a useful example because it is a rational function and you need to know how to approach such a function. In the previous problem, we saw polynomial. Now we are seeing a rational function. Okay. So let's go through the checklist given in the guidelines for sketching a graph. The very first thing is domain. Here is your function. All right. This is a rational function. It is not defined when the denominator is 0. In other words, I want the denominator to be not 0. In other words, x must not be equal to negative 5. So from the real number line, I have to remove negative 5. So that's a whole. So what is the domain? Domain is negative infinity to negative 5 union 5 to infinity. So it's a union of two pieces. All right. The next item in our checklist is intercepts. To talk about intercepts, you have two kinds of intercepts. First is the y-intercept, second is the x-intercepts. You can have more than one x-intercept, but you will have at most one y-intercept. To find y-intercept, we have to set x equals 0 in our function. So this is my function. Plug in x equals 0, right? And I get y equals negative 3 over 5, or the negative of the fraction 3 over 5. So what is my y-intercept point? X coordinate 0, y coordinate negative 3/5. How do I find x-intercepts? I set y equal to 0. Y is 0. What is y? Y is the function expression. In other words, 2x minus 3 over x plus 5 is 0. This is a fraction on the left, so make a fraction on the right. Write the 0 as 0 over 1. Cross multiply. 1 times 2x minus 3 equals 0 times x plus 5. Well, 0 times anything is 0. 1 times anything is that anything itself. Solve for x. Move the 3 over, divide by 2. 3 over 2. So this is 3 over 2 is my x-intercept. Okay, 3 over 2 is 1.5. Now, next item here is symmetry. Symmetry appears in three fashions. One for even function. Yeah, it's symmetric about the y-axis. The other for odd function, it's symmetric about the origin. That is, you have to turn it 180 degrees and you get the same picture back. All right. Another way of thinking about it, take this picture, reflect once more, you get the same picture back. And the third one is about periodic function. If there is a period, the function repeats for every period after that. All right. So three items to be checked in the case of symmetry. To see whether you are an even function, you want to check whether f of negative x is same as f of x. Now, f of x is 2x minus 3 over x plus 5. F of negative x means you plug in negative x wherever you see x. Negative x goes here, negative x goes there. So when I substitute, I get negative 2x minus 3, negative x plus 5. Okay. Don't just stop here and say, hey, they are not equal. See whether you can manipulate things about. Can I get the negative out? I can. Can I get a negative out? I can. Can I cancel these two? I can. I now get 2x plus 3 over x minus 5. Is that the same as this? No. So in other words, even after manipulation, we are not able to get them to be equal. That is, f is not an even function. So you are not going to get any symmetry about the y-axis. Okay. Something like this does not happen for our curve. There is no symmetry about the y-axis. Next question is f an odd function? That is f of negative x same as negative of fx? Consider your fx. Then consider f of negative x. We just calculated it. You see, f of negative x. What about negative fx? Well, it is negative of this fraction. Well, take the negative upstairs. You can choose one of the sides. You can't take negative both upstairs and downstairs. They would cancel. So I'm taking it upstairs just for the sake of it. Now that negative distributes, let's see, does it still equate this? No. You understand? You have to manipulate and see whether you get in any way. Well, even after manipulations, we are not getting f of negative x to be same as negative f of x. So f is not an odd function. Therefore, there is no symmetry about the origin. That is, no symmetry obtained by rotation. So the one about odd is 180. You see, you take this picture, rotate it 180 degrees, you get the same picture back. That is what it means to be symmetric about origin. This happens for odd functions. Well, our function is not odd, so that symmetry is not going to happen. Lastly, is f a periodic function? No. Rational functions are not periodic. We expect functions involving trigonometric function or piecewise defined functions, periodic functions, to be periodic. But polynomials or rational functions or radical functions are not periodic. Okay. The next issue, so periodicity is lost. We don't get that. So there is no symmetry. The next item to study, investigate are asymptotes. Asymptotes come in three fashion: horizontal asymptotes, vertical asymptotes, or slant asymptotes. Okay. So let's see what happens with horizontal asymptotes. To find horizontal asymptotes, you need to take limit x approaching plus infinity or minus infinity. In this case, both the infinities get you the same asymptote, so I have written it simultaneously. Okay. In general, you're not guaranteed that. Like we saw in our previous problem, going to a positive infinity, you got a different limit in comparison to going to negative infinity. But here we get lucky. So we are a rational function. So I take the highest degree of x in the denominator, divide the numerator and denominator by that. So what is the highest degree of x? Just power 1. So x, I'm going to divide the numerator by x and divide the denominator by x. Now simplify. You see, division distributes. So 2x over x gets me a 2 minus 3 over x. X over x gets me a 1 plus 5 over x. All right. Now if I take limit x approaching infinity, I get 2 here, 0 here, 1 here, and 0 here. So that is 2 upstairs and 1 downstairs, in all a 2. That is y equals 2 is the horizontal asymptote, both to the right and to the left. What about vertical asymptotes? Well, our function is not defined when x is negative 5. Remember, you had to remove it because it was in the denominator. So very likely you have to always be mindful, does x plus 5 divide cancel out? So are there any common factors? There is nothing. So this will fetch me vertical asymptotes. Okay. So in this case, where am I? Yeah, I need to take limit x approaching negative 5 from the right and limit x approaching negative 5 from the left. Okay. So we don't know what limits. We know that they are going to be some kind of infinities, either plus infinity or minus infinity. So which infinity? If I come from the left, am I going to positive infinity or negative infinity? When I come to negative 5 from the right, am I going to positive infinity or negative? I don't know. So I need to use test points. To the left of -5, I take test point -6, plug it in my fx. Yes, wherever I see x, I plug in -6. Numerator seems to be negative, denominator is also negative, so this is positive. So when I come from the left, I am going to go to positive infinity. Okay, so keep that in mind. I am going to go to positive infinity. This is a vertical asymptote. Okay, so I am going to go to positive infinity over here. All right. What about when I come from the right? So limit, this was the left hand limit, right? So left hand limit is going to give me positive infinity. Okay, left hand limit. Let's figure out right hand limit. To the right of -5, choose some number. 0. Plug it in. What do I get? -3, right, upstairs, and +5 downstairs. So it's an overall negative. So I'm going to get a negative infinity from the right. In other words, my picture is going to, whatever it does in the middle, when I go close to -5, I'm going to go to negative infinity. Okay, remember that. So these vertical asymptote I do have at -5. Vertical asymptote is a line. A vertical line is given by x equals some number. What is that number? -5. Okay. So you have vertical asymptotes. Now slant asymptotes. As we have horizontal asymptotes. So you see, you have horizontal asymptotes going on both sides. Therefore, you are not going to have a slant asymptote. Okay. Regardless, when you have a rational function, if the numerator has degree 1 greater than the denominator, then we expect slant asymptotes. So what's the point here? No slant asymptotes. Okay. Now I'll stop here this particular video and continue with the next item checklist, and that is intervals of increase or decrease. Until then,